Greetings, folks, and welcome to the Electromaker podcast. This is a midweek roundup of all things Maker and Embedded and Lovely, and this is the audio version of what is a YouTube show, ostensibly. What you'll be hearing for most of the show is me talking on YouTube, where there is video that you can watch as well if you would like on the Electromaker YouTube channel. This particular episode is very RISC V heavy. It's the RISC V Special, or the unofficial RISC V Special, as it were, just because we finally get around to talking about that 10-cent RISC V part, the CH32V003 series of chips that Dave on the EEV blog talked about, and BitLooney recently put out a video of his supercluster, and CN Law, who's one of my favorite YouTubers, as he always does, came up with his entire own platform for programming them without a HAL, and then used it to make a software-defined Nixie tube driver. It's just incredible. And we also talk about learning RISC V assembly from scratch, and also the new Tinkerboard, which is a revision. It's not actually a new version of the Tinkerboard. It's Tinkerboard 1 Revision 2, which I wasn't all that impressed with. You'll hear when we get to it. And so I suppose with all that to get through, it is going to be a longer show than usual, so let's just get straight on with it. We are going to begin this week's show by talking about the CH32V003, which is a new-ish line of chips, which are RISC V, and they are only 10 cents per chip, depending on the package size you get and how many of them you buy. It's sort of set the Maker blog sphere ablaze, lots of people talking about it, and quite recently we talked about the cheapest 32-bit microcontroller that you could get from Puyo, which is actually slightly cheaper than this, but that's ARM architecture, and of course this being RISC V, a lot of people are very excited about an open instruction architecture, and it all kind of started with Dave from EEV blog, and we're going to talk about the video that he put out and a couple of amazing projects that have come out using this very same hardware from Charles Law and BitLooney. But to begin with, let's just take a quick look at the chip itself. So, just before we go into the videos of other people talking about it, this is the page from WCH, WinChipHead. They are the makers of this chip. The CH32V003 is not a single chip, it's a series of chips. There's a few different configurations that you can get in different packages. I've seen it listed, not listed, but I've seen it talked about as the WCH32V003, which I think might just be someone taking the company name, WinChipHead, and smashing it together with the part number. Because as far as I know, that there isn't another whole line of chips from WCH with that name, just in case you see that and you come across that. But in short, I'm not going to insult you by telling you why this is awesome, because I'm not enough of an engineer to know that. I do know that it is meant to be a drop-in replacement for the STM800 something. Again, this is something that Dave talks about with a lot more authority in his video, and I'm sure if you follow this channel, you already follow the EEV blog anyway. But yes, in short, it is a 32-bit RISC V MCU, an industrial-grade general-purpose microcontroller that supports a 48 MHz system main frequency with wide voltage, one-wire serial debug interface, low power consumption, an ultra-small package, etc. And it has a built-in group of DMA controllers, a group of 10-bit analog-to-digital converters, a group of op-amp comparators, multiple timers, and standard communication interfaces like USART, I2C, SPI, or SPI, depending on how you call it, and a few other things as well. I will link this page in the description. If you do decide to get one of these boards, I bought a development kit and a programmer off AliExpress. It cost about €9.50 shipped to me, I believe. You'll maybe want to go back to this page if you do decide to do that, as I did, because the datasheet is there, the reference manual is there, which is actually very well written, and even for a noob like me is not all that hard to follow. And they also have their own integrated development environment, which you may or may not want to use depending on what I show you next. However, it is an Eclipse-based environment, and it is not all that hard to get up and running, which brings me on perfectly to Dave from the EEV blog, who is someone I'm sure if you watch the Electromaker Show you are already familiar with. In fact, one of the only reasons I don't feature Dave's stuff on the show all that often is because I feel like it's almost pointless to do so, because he's so ubiquitous on the internet as the guy who talks about the kind of stuff that I talk about in the show, but with a much higher level of authority, who is an electrical engineer, whose lessons on how things work have been instrumental to me learning anything over the years, really. More often than not, it's one of Dave's lectures combined with a few other people that get me over the hump of understanding something. So yes, anyway. Dave's video on it is one of the things that really set everyone talking about this in the first place anyway. Just talking about the chip in general, talking about what it is capable of, and also showing his experience about getting the Eclipse IDE up and running. It's not called the Eclipse IDE, it's based on Eclipse, isn't it? It's called Moon River or something like that. Let me just check. Mound River Studio, which is an Eclipse-based studio specifically for this board. And he shows him getting it up and running, the trials and tribulations he had, but there were not many trials and tribulations, which is kind of nice. Getting something like this up and running, the unknown parts with perhaps not very great support can be a bit of a nightmare, as anyone who has had to try and do that will attest. Luckily, as a hobbyist, I haven't really had that many issues with it, but there have been a few times I've bought things on a whim that I've more or less had to shelf because I don't know what to do with them. It seems like this isn't the case. And Dave goes through a great, just get it up and running, get it flashing, and shows that there's a high amount of example code already out there for it that comes shipped with it. You can download the zips and it'll give you examples of pretty much everything that the chip can do in code in the IDE. So yes, if you haven't already seen this video, this is more or less the video that sparked it all. And if you are interested in getting into the whole 10-cent RISC V, you can't call it a movement, no, interest. If you're interested in it, this is a great place to start. What a crazy world it would be if people started movements around 10-cent parts. The cult of cheap RISC V. Moving on to CN Law, and yes, that is a Nixie tube, a proper Nixie tube, a high voltage Nixie tube, and you may be wondering what that has to do with these 10-cent RISC V parts. He decided that this 10-cent RISC V part would be the perfect thing to drive a Nixie tube, which is an obscure thing for a non-electrical engineer or someone who doesn't know much about electronics to think about. But it also comes down to the fact that he found these beautiful tiny little flyback transformers and basically used the same 10-cent RISC V part we've just been talking about as a software, to control the flyback transformer. It is a software-controlled flyback transformer providing the right voltage to a Nixie tube, which looks absolutely beautiful and stunning, and even fades between all of the numbers. There are various points in this video where I see the Nixie tubes and my thumbs start itching, and I think there's no point in buying one, Ian. You don't have the time to play with this. And also, the level of electrical engineering required to get this up and running is incredible. And I would want to do it myself, despite the fact that Charles, with this project and every project that he's done, it's all open. Open hardware, open source. If you are one of his patrons that lives in the United States, he will be sending one of the programmer boards and one of the Nixie Tube development boards he has made out to you for free. He's quite an incredible YouTuber and streamer, and if you are a fan of people who like to get right down to the bare metal and close to it, you will really like his GitHub repository as well. Specifically, his work on the ESP3266 is kind of amazing. He has a real penchant for removing hardware abstraction layers and making very bare bones get up and running things for various things, and this is no different. He's done it for this. His CH32V003 fun repository gives you a bare bones header file that will allow you to just get going programming pretty much straight away with the chip without having to use any of the software, although as Dave showed in the previous video, that's not that difficult to get going as well. Now, Charles mentioned in his video that he wasn't the first creator to get a video out about this. The first kind of maker creator to talk about it on their channel after Dave, because BitLooney came out with the idea of a RISC V supercluster. Because he thought, well, these are so cheap and they're so small, these parts, why don't we put 16 of them onto one board, which is exactly what he has done. So what exactly is the supercluster? Well, it is 16 of these chips all put together with a bus in between them. Now, it is an open drain bus and a protocol that BitLooney is building himself. There are so many things about the idea of this project that are fascinating. But if I was going to try to explain it in very brief, you have the 16 chips on top that can communicate with each other. You have a master MCU underneath it, and then you have these two boards that kind of clip together. And on the outside of those boards are all of the inputs and outputs of the 16 board chips on the inside board that you can take on or off. I've explained that terribly. You should probably just go to the BitLooney video and let him explain it rather than the failure of an explanation I just tried to give. But yeah, the idea of these 16 chips on a board that can pop on or off the controller board, the controller chip underneath it, and have all of the input and output on the side is just such a lovely engineering idea. And as he points out towards the end of this video, this is by no means the limit. You can fit a huge amount more of these onto a board if you use a different package, or you could just make a much bigger board. And as he asks in the video, how many is honestly too many? me, and I'm pretty sure he's going to try and find out. His open drain bus protocol idea is just amazing as well. I love it when people try to design things like this from scratch, because it allows me to understand them better, because seeing someone who has a fair amount of knowledge, certainly a lot more knowledge than me about this kind of stuff, do things from the basics is a really, really good way to learn, which in fact brings me perfectly onto the next thing that we're going to talk about in this episode. So, the CH32V003, the 10 cent, well, if you get it in the right package size and in the right numbers, RISC V part. That's not as good as a headline as all the other sites have given it, but we finally have covered it. I think those 3 videos are a great introduction to it and are very entertaining. There'll be links to them in the description. I may have already mentioned this. I bought a CH32V003 development kit. I can't remember which variant of the chip it is, with a programmer from AliExpress, and it cost me less than €10. I'm afraid I can't list that because the listing that I got is gone now, but there are many others like it, so you'll be able to find it. When it comes to RISC V and ARM and x86, I always have a bit of imposter syndrome because I get excited about RISC V, and I do understand why an open source architecture that you can use without having to license it or pay for it is a good thing. But without knowing exactly how instructions are given to a processor to build the basis of a system that will eventually become a full operating system or an RTOS or an MCU, it's always been an uncomfortable thing for me to talk about. Until recently, I haven't really had any idea about how all of that works, but I've been remedying that, and I want to share 2 things I found incredibly useful. One is a YouTube series and one is a book. This is the YouTube channel of Sarah Jamie Lewis, who has been building an OS completely from scratch using RISC V architecture and streaming that process on Twitch. These videos uploaded to the YouTube channel are VODs of those streams, and so far they are among the most useful things I've come across for learning about RISC V and how you can start with nothing and build an OS out of it in an emulator, in this case QEMU, or QEMU, whatever, however it's pronounced. This is my favorite style of tutorial because Sarah is clearly a deeply knowledgeable person who has built operating systems before, who has a wide software engineering background. Her blog is incredible and goes way over my head in every single way. And yet this is her relearning RISC V architecture and building things slowly from scratch. It's not a point-to-point tutorial. It's not going through everything in absolute excruciating detail or saying, let's learn the instruction architecture one instruction at a time. It's a practical, let's get an OS off the ground video on this day naught, which I'm only halfway through. So far, I've been able to follow all of it in a way that actually makes complete sense to me, which is incredible, given how dense and difficult the subject matter is. So as I said, I'm only halfway through day naught, and it's been incredible for me. I've learned more from Sarah's videos than I have from the various other times I've attempted to learn about any kind of instruction set architecture in the past. And I have skipped ahead ever so slightly, and yes, Doom does end up running on this operating system because Doom must run on everything, we know this. But the time commitment here is obviously large, and I understand that not everyone has the capacity to watch this stuff. One of the reasons that I think that I am able to do this is that it's actually easier for me to see long content like this, especially late in the evenings when children are sleeping, for example, than it is to actually sit down and do piece by piece tutorials. In terms of learning concepts, this is something that is fantastic. However, another thing that I've always really, really loved is learning from actual books, physical copies of books, and that's what we're going to talk about next. So, some time ago I wanted to understand how real-time operating systems worked, and I found a book by Warren Gay on FreeRTOS with the STM32, which is perfect. I have a few STM32 Blue Pill boards and a programmer, and it turned out to be a fantastic book for learning not only the basics of how FreeRTOS works, but it generally taught me a lot about working with libopencm3, I think, which is one of the many libraries you can use with STM32, bare metal from the command line, no STMcube IDE or any of that kind of stuff, and I learned a hell of a lot from that book. And again, a lot of it is talking about protocols that go way over my head, and there's several times in the book where Warren himself says, like, this chapter of this book is not enough to talk about how the USB protocol works, for example. Books have been written about how the USB protocol works. But the reason I wanted to mention this is because the book that I'm going to recommend right now is RISC V assembly language programming, which is by Warren Gay, same guy. This is something that you can get a physical copy of. In fact, I got a physical copy of it that came with an ESP32 C3 dev kit. You can get this as an ebook as well. But as I said before, there's something about physical books I really like. At this stage, I do want to point out that I am very, very at the start of this book. I have been reading it in bed before the lights go off. I haven't even installed the software libraries on my computer yet. But the thing I like about this is that it takes it from two angles. One is that, yes, the ESP32 C3, and it teaches you about RISC V architecture and from a 32-bit perspective, but it also sets up a 64-bit QEMU virtual machine, much like Sarah does in the videos we were just talking about, and to show you the difference between the two types of instruction architecture there too. We are so short for time this episode, I'm just going to sort of leave it there, really. If you are interested in learning about RISC V assembly language, I highly recommend Warren Gay as an author. I'm not really far enough into this book to give an honest review of it yet, but so far I've really liked it. This is the ebook version of it, and I will link the ebook version of it because if you already have an ESP32 C3 board, you might just want to get that. However, under the books section, you can find the physical copy of it as well. Just be sure when you buy it that you are getting the version that is bundled with a board, or maybe you just want to get the book. But it does say it includes a dev kit board with it, so maybe it comes with every paperback. I honestly can't actually remember the circumstances under which I bought it. I just remember thinking, yes, this is something I've been wanting to brush up on, and now I can. If you are enjoying the Electromaker Show, consider subscribing to this YouTube channel and liking this video. Also, the subscription menu as a drop-down has an option to give you all notifications, which will give you a notification in the top right of your YouTube window whenever we have a new episode or video up on the channel. However, the best and most direct way to support our show and everything we do is by shopping at the Electromaker store. At electromaker.io/shop, you will find pretty much everything from everyone in the embedded sphere, from your first maker kits and boards that you might want to buy yourself if you're a beginner, or as someone else as a gift, right up to some quite heavy industrial side of things. If you are looking to buy a large number of things for your work, consider looking at us as well. We can do bulk supply too. We have an excellent Trustpilot score and can ship anywhere. Yes, so thank you so much for the continued support you're showing us, and let's get on with the show. Now, on last week's show, we started a competition to win a Zima board, which is an x86 single board server, which is essentially a single board computer, but it's set up to be, well, a server. You can attach up to 36 terabytes worth of storage to it and use it as a NAS. It has dual Ethernet ports, so you could use it as a router. I personally have been using mine just as a way of having a home-based Dropbox and as a little bit of a Plex server because I'm rewatching The Sopranos only for the 17th time or so. Anyway, if you'd like to find out more about it, you can head to the link in the description, which will take you to the Zima board website. However, we did start a competition for someone to win one, and it is time to choose that winner. And the winner of the Zima board is Tim Malin, who said, I will convert my Raspberry Pi 4-based home server to a Zima board, migrating the Pi hole using a Star Trek theme, of course, a VPN server and NAS, adding the PCIe to NVMe adapter and use it as an excuse to buy some shiny new NVMe drives, also the SATA Y cable because mo storage is mo better. I could not agree more. Finally, designing and printing a Zima board-inspired enclosure to keep it all looking neat and tidy and just that little bit sci-fi. And the Zima board itself does look a little bit sci-fi, doesn't it? I do actually quite like that. The aesthetically pleasingness? No, it is aesthetically pleasing. Anyway, congratulations, Tim. We'll be in touch with you as to how we can get that out to you. Thank you to everyone who entered, and of course, there will be more giveaways coming up. I've had a little sneak peek as to the product of the weeks that are coming up over this year. Some of them are pretty amazing, and I'm really looking forward to giving them away to you lot, our community. And yes, with all of that said, let's get on with the rest of this decidedly RISC V flavoured show. We're going to close out this week's show by talking about two new boards very briefly, one of which is RISC V and one of which is not. So let's begin with the RISC V one, shall we? This is the ESP32H2, which is something I believe we did talk about on the show when it was first announced, which was a couple of years ago now, I think, at the very least at the start of last year. But as CNX Software have pointed out here, they're only just now starting to sell the dev kit modules for the ESP32H2. In August 2021. It's right in front of my face. That's when this was originally announced. There are so many variants of the ESP32 out at this stage that I'm not going to exhaustively go through everything that this can do, but I do believe it is their first RISC V microcontroller that is designed with Bluetooth low energy in mind, Bluetooth 5.2 low energy, and it is, of course, a product of the time in that it is Matter compatible, Thread compatible, Zigbee compatible, and will probably be very, very cheap. Interestingly, one of the things this article does mention is that these boards are sold with the revision version of the chip, sample chip revision 1, because the chip is not in mass production yet. While the development kit is available on AliExpress AliExpress. The ESP32H2 Mini 1 is not, probably because mass production of the H2 has not yet started. So, the AliExpress listing is just here. I will leave a link to this in the description of the video. This is no longer available already. Wow. Well, I will leave a link to this in the description of the video either way, just so you can find out a little bit more about it if you would like. If you are able to get your hands on one of these because you think you'll be working with the H2 in future, I can see that potentially being useful for you. Otherwise, for the rest of us, we might just wait until it's in mass production. That would probably be the sensible thing to do. And just before we finish the show, the only non-RISC V thing in this week's show is the fact that there's a new revision of the Tinkerboard. Now, this is the revision of the revision 2 of the Tinkerboard 1, if you could call it that. There is the Tinkerboard S, the Tinkerboard 2, the Tinkerboard 2S. The differences between the mainline Tinkerboards and the S variants is that the S variant has storage, eMMC storage, 16 gigabytes, I believe. I can check that, yes. And I believe that is the only thing that is different about them. In fact, as far as revisions go, this is a very, very small one. Given that the original Tinkerboards came out in 2016 or 2018, I may be wrong on both of those counts, please, apologies if that is the case. The only thing I'm noticing as any difference here is that the RK3288 now is the CGW version of the processor, which has an integrated ARM Mali graphics processor. Having done a little bit of rabbit holing about this when I was trying to work out what the differences are, in terms of user experience, it seems that the original processors, these RK3288, advertised up to 1.6 or 1.8 gigahertz of performance, but they weren't stable at actually running at that speed and had kind of overheating issues and all that kind of stuff, which should have been cured with the use of the slightly updated, albeit almost the same designation of processor. I wanted to mention it in case you are someone who is using the Tinkerboard in your day-to-day and you weren't necessarily aware that there is a revision. The Tinkerboard is an interesting one. There's a fantastic book about the Tinkerboard written by Liz Clark, who's from Blitz City DIY, and I bought that to support Liz and read the book, and it does seem super interesting. But by the same token, even now, when it's quite hard to get your hands on other boards, namely Raspberry Pis is the one that always comes up, the, I believe, $150 price tag for the Tinkerboard S Revision 2 is going to be quite hard when you think about things like the Orange Pi 5, for example, which is like, what, $80? And it comes with a much stronger, still rock chip processor and generally more across the board. It seems like an interesting revision. Of course, I don't know how these things work. I don't know how the ideas under the hood. Maybe they have a huge user base already using Tinkerboards, and this revision is going to be a huge quality of life thing for them. But yes, it does still seem like quite an expensive board, but it doesn't get you quite as much grunt as a lot of other ones would. I wanted to check that I was actually correct, and it's 150 euros for the Tinkerboard S Revision 2, 2 gigabytes of RAM and a 16 gigabyte eMMC, which does seem like not very much hardware for your money. I was trying to kind of think of a positive spin, because I feel like I was maybe a little dismissive of it, but really, yeah, it is quite a lot of money. Maybe you're getting build quality out of it. It's been a long time since I've held a Tinkerboard, but with other brands of cheaper SBCs, sometimes they are dead on arrival. Maybe that's not the case with these boards. Maybe the quality control is higher. But yeah, as I mentioned, unless you're already quite invested in the Tinkerboard, I don't see necessarily all that many reasons why you'd want to spend this much on a board with this little power. Perhaps I'm wrong. Please do let me know in the comments if that is the case. That has been our show. Thank you so much for joining me, and thank you for all the support that you continue to show us. I forgot to remind you at the start of this episode, but if you do want to buy anything at all in terms of maker and embedded hardware, from the very first beginner kits through to large numbers of things for your work, do consider checking the Electromaker store at electromaker.io/shop. Because yes, that money is what keeps us afloat. That's what keeps us running. We don't run ads on our podcasts or have a Patreon or any of that kind of stuff. There will not be a show next week. There may be a podcast if I am able to scrape some time together, but I will be in Bucharest for the NXP Cup Finals, which is the NXP Autonomous Driving Competition. And so it's going to be very difficult for me to find time to get anything done. But if I do manage to, I'll be talking to you from Bucharest. If not, I will be back with you in 2 weeks, probably talking about the NXP Cup along with any other news that's happened between now and then. But for now, I hope you have a fun, safe and creative week, and I'll chat to you soon.